Let's talk about centralized versus distributed architecture in this video. This is one of the ways to look at software architecture. There are many other ways, perspective or lenses to look at software architecture. That includes things like communication, deployment and things like that. And centralized versus distributed is just one of those ways to look at software architecture. And when we are looking at software architecture from this distributed versus centralized perspective, it answers where does control and responsibility live. In centralized architecture, the control lives in one place. Okay, that is what centralized architecture is all about. It does not mean we have just one component or part. So if we look at this example, here we have two parts. We have a website and a database which is connected to this website. Here, this architecture can still be a centralized architecture even though it has multiple components if only one of these two components has full control. So if it is a website which just uses the database to store and retrieve data, then the control may live only within the website. Or on the other hand, if the website is completely data driven, then all the control might live only in the database. If that is the case, then even though we have multiple parts, this will still be a centralized architecture. So in centralized architecture, we'll have one part that knows what is going on, and that part is also in charge. In this case, if we take this particular example, if the website is having all the control, then the website is in charge, and this is the one which decides what is happening and what is going on. Okay. Now, some of the advantages of centralized architecture includes things like centralized architecture is easier to reason about because we have handful of components or just one component, and that component is going to be having all the control. It is easier to understand what is going on. It is easier to reason about what is going on within the system. Also, centralized systems are easier to develop and test because we have very few moving parts. It is generally easier to develop and test compared to distributed architecture. And normally, most systems starts this way. This is because this is a natural way to start any system that grows organically. Unless you plan a system to be distributed out from the beginning, you normally start that system as a centralized architecture, and as the demand and requirements and complexity increases, you will change the architecture to decentralized architecture if that is the right solution. Example for centralized architecture include things like n-tier architecture. So n-tier architecture is just one example for centralized architecture. Now let's talk about distributed architecture. In distributed architecture, as opposed to what we have seen in centralized architecture, the control might not be in just one place. Okay, it might be spread across multiple components. So if we take this as an example, we have the system. The system has multiple components, and each of these components will have some responsibility, and these components will have some control. So the control is not going to be in one place. The control will be spread across multiple components. So like I said previously, each part is going to be autonomous and they have some responsibility which is only for that particular component. And normally these components communicate with each other to coordinate some work. Okay, so if we have some work and that work need to be done, then these components have to communicate with each other to complete that particular work. So if you imagine this as an e-commerce site, for example, this might be a component responsible for product listing, and this might be a component responsible for payment processing, and this might be a component responsible for communication, like sending emails and SMS and stuff like that. So when someone places an order, they need to view the product using this component, and they need to pay for that product using this component. And once the order is processed, then we need to send some emails and SMS, right? So that might be done using this component. This is how these components coordinates to complete a particular task. I just want to make it really clear that distributed architecture does not mean it is better. It is not at all better than centralized architecture. Distributed architecture will be suitable for some type of system, whereas centralized architecture might be suitable for some other type of system. it is not to say that one architecture is better than the other architecture. Okay, so in distributed architecture, we simply have more moving parts. So in a centralized architecture, we'll have few moving parts. Normally in a distributed architecture, we'll have more moving parts. And some of the advantages for distributed architecture includes things like independent deployment. So we'll be able to deploy each of these components independently, and we'll also be able to scale each of these components independently, right? So if we have suddenly high demand for product component, then we'll simply be able to scale up this component alone. And if we don't have much demand for communication component like this, then we can scale this down to save cost. Some of the disadvantages of distributed architecture includes things like network failures. So if we have network failures, then it will affect the system, because we have multiple components and normally these components are going to communicate with each other through some sort of networking mechanism. If we have network failure here, for example, then these two components can't communicate with each other. This means we'll have some impact on the overall functionality provided by this particular system. And also, due to network failure, we'll also have partial failures. If this particular component is cut out, if this component is responsible for communication, which is emails and SMS, if this particular component is cut out from the rest of the system, then the system will not be able to send any emails or SMS. Okay, so that will have some impact on the system. So this is an example for partial failure. And also, distributed architecture generally is going to be operationally high complex. Because we are going to have many moving parts, it is generally harder to develop and test compared to centralized system. And also because we have many moving parts, it is going to increase the operational complexity, which includes ongoing maintenance, fixing any bugs and things like that. One of the example for distributed architecture is microservices architecture. This is just one example for distributed architecture. And like I said previously, this centralized versus distributed is just a perspective. We have different perspectives or lenses to look at software architecture, and the centralized versus distributed is just one of those perspectives. And there are some other perspectives through which we can look at the software architecture. That includes things like deployment. If we look at the architecture from the deployment's point of view, then we will list all the components, then we will look at where each of those components are deployed and how they are deployed. Another perspective to look at is data ownership. If you are looking at architecture from this perspective, we'll list all the components, then we will define what component is responsible for what data, which component owns what data. One more perspective is communication. In this perspective, we'll list all the components and we will define how each of those components communicate with each other and how they interact. So that is another perspective to look at software architecture. So for this series, I'm going to just use centralized versus distributed architecture perspective, because this perspective, in my opinion, is the best perspective, and from this perspective, we'll be able to explain all the other perspectives that we have seen here. And also, from this perspective, it is easier to explain all the major architecture style. That includes things like microservices architecture, event-driven architecture, N-tier architecture. So all of those architecture styles can easily be explained from this perspective. So that is why I'm going to stick to this particular perspective for the rest of this series. So that is all I wanted to talk about in this video. I hope this is useful. Thank you.